Okay, great. Thank you everyone for joining us today for our public health seminar series. We're thrilled you could make it and happy that our power seems to be working here at the university. We're really thrilled today to begin our topic of New Jersey's assassin bugs and the risk of Chagas disease, myth or reality. As you know, our guest today is Dr. Dina Fonseca, and we'll do a formal introduction of Dina in just a moment. Today's program will be a webinar that will review the life history, ecology, and distribution of assassin bugs and the pathogens that they can transmit, focusing really primarily on New Jersey. The public health core competencies that we'll be addressing include 6B1, 6B3, and 6B4. And as you know, those come from the public health core competencies for public health professionals. Just as a reminder, most of our webinars do make their way onto train.org, the national clearinghouse for a variety of public health education programs. We have a few of those programs listed here, and in addition, we can send out a listing of all of the programs that are there to anyone who may request that. And you can see Carl Donaldson's email at the bottom of the screen, and we're happy to distribute that to you. We will be using Zoom today. As many of you know, we started doing that a few programs back. The chat box is a command that's at the bottom of your monitor, and we ask that you use that to type in your questions. And near the end of the webinar, we'll go ahead and ask our presenter those questions so that those can be answered, and we'll allow a little bit of time after that to do so. Dr. Fonseca, I'm going to invite you to go ahead and share your screen now. And while you do that, I'll introduce you. So we are thrilled to have Dr. Dina Fonseca here, who is the director at our Rutgers Center for Vector Biology. She's also a professor of entomology, ecology, and evolution, and microbiology. Dr. Fonseca is a molecular ecologist who examines how populations of invasive species change upon their arrival and as they expand, especially in the case of disease vectors. Dr. Fonseca works with professional mosquito control programs using vector biology, ecology, and evolution to develop effective and efficient strategies for control. She's also involved in a wide variety of national and international organizations addressing those topics. She spearheaded an urban mosquito control effort by residents through a group called Citizen Action Through Science, and she is also the founding member of Worldwide Insecticide Resistance Network. She's also received her BS in biology and geology from the University of Coimbra in Portugal, her MS in biology from Central Michigan University, and her PhD in ecology and evolution from the University of Pennsylvania. She's been working here at Rutgers since 2007 and became a full professor here in 2014. So Dr. Fonseca, I think you have control of the slides right now, so I think you can take it away.
Hi, hello, Colleen. Thank you. And thank you for being so resourceful. I can't believe you actually being able to do this during a power outage. Work. Well, I can't see anybody, so this is going to be a little bit of an interesting experiment, but here we go. Thank you for the opportunity to take a look at Chagas vectors and Chagas disease sort of from a New Jersey perspective. It's actually been a really interesting experiment and experience for me. So, okay, so here we go. So New Jersey's assassin bugs and risk of Chagas disease, myth or reality. The information here, how to contact me, is on this slide, also be on the last slide. And okay, let's start. So why are we here? At least why are some of us here, or at least partly why are we here? Well, we're here because NewJersey.com came up with a heading, blood-sucking kissing bug could be headed for New Jersey, and it's far from romantic. And that sort of started everybody talking. There was also a discussion on WPUR about the possibility that New Jersey could be marked as a potential landing spot for these anything but kissable flying insects. And finally, in Point Pleasant patch, and this is just examples of what has been sort of circulating, No one needs to tell, name withheld, how excruciatingly painful it is to be bitten by the kissing bug. So I've sort of taken these themes and came up with a lecture plan. So first, what are kissing, or what are assassin bugs? Are they the same thing? Are they different? Are they dangerous? Do they hurt? I mean, the statement before mentioned that they were painful. Do they occur in New Jersey? If not, will they occur in New Jersey? And finally, what is the best course of action? And I actually would really invite your feedback at the end of this discussion, or at the end of this presentation. And in any case, if you are stuck or need some clarification that really prevents you from letting me go on, interrupt. I don't know exactly how you do that, but I'm assuming you send a message, and I'll clarify. We'll see how that works. Okay, so are we talking about kissers or assassins? And by the way, today being Halloween, this is a particularly well inspired theme. Well, these are insects. They're class Insecta, order Hemiptera, or so-called true bugs, and in particular, they're all part of the family Reduviidae. These are, and you'll see in this picture, two examples of the assassin part of these bugs. So these are predatory insects, and in fact, they're good. They're biological control agents. The two pictures on the right are one adult and a nymph. The nymph is right there spearing an agricultural pest. And they basically feed on other insects. In fact, if you Google assassin bugs, there's some pretty cool videos on YouTube about how stealth they move, how incredibly good at their assassinations. It's a bit of a ninja bug. And actually on the left, you have what's right now one of my personal favorites, a worldwide invasive Reduviidae personatus, actually named by Linnaeus, since this is originally a European insect. What you're seeing there is called the masked bandit, because the nymph, which is what you're seeing right there, covers itself with dust and sand and particles and lives inside our houses. They'll feed on cockroaches, they'll feed on bed bugs. And so these are the assassin bugs. So again, assassin bugs, they're good at biological control, and overall, they're good. On the other hand, by the way, and sorry, I forgot to mention, so the masked bandit that you saw back there, that was a nymph. Here's the adult, and you will see in particular, if you take a look at the head, those mouth parts that you see there in the wheel bug in profile particularly well, this very long proboscis that they use for piercing and injecting sort of a liquefying enzymes to feed. They basically feed on their prey like they were drinking a smoothie after having made the smoothie. So these are the assassin bugs. Now there's also, in part of the family Reduviidae, there are hematophagus, and that's really, that's where the kissing bugs come in. Those are bad, and those are bad because they're blood feeders, and because they're blood feeders, they're the primary vectors of human American trypanosomiasis, or Chagas disease. Picture there, you're seeing a vector and the pathogen. The pathogen is a flagellate protozoan, kinetoplastid, have this sort of the flagella that they use for moving around when they're in circulation. So the agent, Trypanosoma cruzi, there are 6 recognized lineages. That's the species of pathogen that is responsible, that is the agent of Chagas disease. The epidemiology, this is largely a rural problem in South and Central America, but, and this is why we're here, it's a growing urban problem in Central and South America, and it's potentially an emerging problem in North America. It's primarily associated with substandard housing, because these bugs basically are living in the crevices of our houses and then getting into people's bedrooms at night to feed on them. So they're nocturnal, and they're attracted to CO2 like a lot of hematophagus insects. There's 6 to 7 million estimated, so known infected people. The estimates go all the way up to 8 to 12 million. So that's the prevalence, the currently number of infected people. There's actually 120 million people at risk. There's 300,000 new cases recorded every year. So the incidence is about 300,000 cases. And those, you have about 50,000, not of those, but in general, you have about 50,000 deaths associated with Chagas per year. So very considerable, but not incredibly high. However, it's associated with cardiac disease. And we'll talk a little bit more about why that is. So these bugs affect the heart muscle. They can also, the same pathogen can also be transmitted by transfusion, through transplants, can be passed congenitally from mother to offspring, and it can be obtained orally. And we'll talk a bit more about that in a minute. So the Trypanosoma cruzi, the pathogen that is responsible for Chagas disease, its life cycle is two-pronged. So there's a life cycle in the vertebrate host, in this case a human, and then there's a life cycle in the vector. So this is a picture from CDC. On the right, you have the human cycle, and on the left in the vector. Basically, there are, in the human, the pathogen is injected, or it's not injected, it enters the circulation as a flagellate. It goes inside a smooth muscle, which can be, and also heart muscle. So it affects both the heart and can also affect bowel movements by stopping peristaltic motion. So they can lead to very enlarged colon. And then it can routinely come back into this flagellate, the trypamostigode form that is motile and is in circulation. It can then be picked up by a kissing bug when taking a blood meal, and it develops in the kissing bug. And notice it develops in the kissing bug in its gut. So the T. cruzi, Trypanosoma cruzi, does not actually invade the kissing bug. It develops in the gut, and then the infectious forms are excreted when the bug defecates. So the parasite is not actually injected into the next host, but it's more rubbed into the pierced skin, or it can also be absorbed through the mucosa. So as the bug is taking its blood meal, and if it defecates the parasites into the skin, the person may, at that moment or later, just basically while rubbing this area that got damaged by the bug feeding, can then actually introduce the pathogens into the wound, or it can introduce the pathogen to their eye mucosa or mouth mucosa. In fact, the infection can be acquired orally by eating infected fruit. And just there's been many episodes, in the latest one, a very notorious case in Caracas, Venezuela, where over 300 people were infected with Trypanosoma cruzi, and because of drinking acai fruit smoothies. So beware. Clinical signs of Chagas disease are if there is a bug involved, a Romagna sign where the sort of infection, swelling of the eye mucosa, if that's how the pathogen got into the host, or if it was, sometimes you can have local reaction in the area of the bite, so-called shigoma. And this is sort of an important point. The acute phase is really primarily asymptomatic. So only about 5% of cases experience any kind of symptoms, which are, again, they're malaise and fever, and they can last for 4 to 8 weeks. There's rarely, but does happen, about 1% of kids. So 1 in 2,500 infections can actually be deadly. It's mostly in kids. The second phase is actually an indeterminate phase, where most people that actually were infected don't ever have any kind of problems. And finally, you have a chronic symptomatic phase where you can have cardiac damage and cardiovascular alterations. And like I mentioned, because of the stopping and peristaltic movement, you can have megaesophagus and megacolon, which can be very debilitating. You notice there's references at the end of most of my slides. So if you want to obtain more information, that will be the papers to follow up with. I can provide more if you're interested. So sort of taking this in as a summary, basically you have an acute phase, which is relatively short with relatively low mortality. Then you have an intermediate, about 8 weeks, where really that seems to be intermediate between an acute phase, a chronic phase, and then you can have nothing happen, which is most cases. Most people have no sequelae whatsoever from being infected with the Chagas pathogen, but in a few cases, and that can happen, most cases happen decades later, 20, 30, 40 years later, they may have a heart attack or they may have gastrointestinal disease as a result. This kind of symptomatology means that it's pretty hard to know, to follow up the epidemiology, because it's hard to know who got infected unless you're doing a lot of serology. Now, that's a bit of a quick summary of the Chagas disease. And again, primarily this is about what we see across the world. This is and I should say, this is a Central and South America primarily disease. It's a New World disease only. Now let's get into the US. In the US, there are 11 species of kissing bugs. They're all listed here. The little size on the side, that's about an inch. So these are relatively large insects. These are not subtle insects. When you see them, you see them. But normally you don't see them because they are nocturnal. They feed at night and they're quite stealth. The kissing bug that we usually referred to, the most common kissing bug is the so-called the big bed bug, Triatoma Sugah, and we'll talk a bit more about that species. Triatoma Sugah especially feeds on armadillos and opossums, but these US kissing bugs feed on wood rats, cotton rats, armadillos, raccoons, possums, frogs, dogs, chickens, horses, and humans. Compared to the South American, Central American species, they're less likely to bite humans, but the big bad bug, Triatoma Sugah, will feed on humans. They also, and this is kind of an interesting and critical parameter, they take longer to excrete the blood after feeding. And so basically, if the bug feeds on blood and then poops someplace else off host, no transmission in general, no transmission is going to happen. So this is actually a critical parameter. They take about 15 to 20 minutes, depending on the species, to feed, and good vectors will start basically processing the blood and start excreting some of the excess fluid, which will contain the Trypanosoma while feeding on the host. And also a big important part of this, that good housing stock in the US does decrease the likelihood that these kissing bugs are indoors. But we're seeing, and this is from the literature, we see increased exposure due to camping and hunting, which frankly starts to give us a bit of a whiff of Lyme disease. So for those of you familiar with Lyme disease, a tick-borne, very common disease here in New Jersey, exposure during camping and hunting may be also an important part of it. Now, what's the kissing bug life cycle? Kissing bugs all have 5 nymphal stages. What you see there on the top are the first instar, all the way through the 5th instar, and then the adult of Rhodinius prolixus, a very good vector of Chagas disease in South America. The nymphs are, this is an insect that does not have complete metamorphosis, so it has partial metamorphosis, which is basically the 5 nymphs. The nymphs are not, they don't have wings. It's kind of hard to see, but basically they have, the 5th one has a little bit of a stub of the wings, and then the adult has the full wings. They don't fly that much. They will fly if needed, but primarily these are bugs moving around by walking on the ground. All stages have to feed on blood. So all nymphal stages need a blood meal before molting, and they have a seasonal occurrence basically between May and October, depending on the latitude. But even in the southern US, this picture here is actually from a study of Triatoma Sugah in New Orleans. And so you'll see that there is primarily, they're common in June through September. Those bars are the numbers. The dark is the bugs found inside houses, and the lighter color is outside the house. And the proportion infected is found, is shown there as a stipple. And you will see that up to almost 100% of them can be infected, and that's with T. cruzi, with the Chagas pathogen, which occurs here in the United States, here, New Orleans being here an example. So the rates of infection rise among nymphs and peak in adults. And so often you'll have, on average, adults infected with 40 to 60% of them will be infected with T. cruzi in some parts of the United States. So is Chagas an emerging disease in North America? Well, no, because actually there's a study shown here on the bottom, Barnabé et al. They did a thorough phylogenetic analysis and found that US T. cruzi strains actually indicate the parasite is indigenous to the US fauna. It's found here, it has different lineages than what is found in Central and South America. So for those of you that are basically thinking that we're just getting, it's a bit like Zika, where the pathogen is coming from Central South America, no, that does not seem to be the case, which indicates that we have competent local vectors and there is ongoing transmission of Trypanosoma cruzi in the United States, but it may simply be sylvatic, just going between, possums or armadillos and the local kissing bugs that are feeding on possums and armadillos. However, some local vectors, like the big bedbug, Triatoma sanguisuga, are urban and they bite humans. We know that. Case numbers are increasing, and we'll talk about that in a bit more. And we also see high rates of infections in dogs. Plus, the question then is, are the vectors moving north? That's what some of discussion has been. Well, do kissing bugs occur in New Jersey? We're pretty north up here, so do they occur in New Jersey? This is actually the picture from the CDC webpage, the Centers for Disease Control webpage, that shows the distribution of all those 11 species of kissing bugs across the United States, and it has New Jersey and West Virginia as potential. But however, if you read the literature, Blatchley, 1926, reported that Triatoma sanguisuga was present in New Jersey. This record apparently was overlooked by Froschner with 1988, which is that citation on the bottom, which is basically a chapter on assassin bugs in general, the family Reduviidae in particular, that is in the book Catalog of the Atroptera, or True Bugs, from Canada and continental United States. So, however, if you look at Blatchley, and you can actually download this from the web, if you read Blatchley, you realize that regarding Triatoma sanguisuga, he states that Lacombe, which is the person that first presumably described the species, says that this insect inflicts a most painful wound. Also, Blatchley quotes Marlatt from a study in 1896 that says it feeds on bed bugs, that Triatoma sanguisuga feeds on bed bugs, especially those already charged with human blood, and has a buggy odor, even more intense than that of the bed bug. And Blatchley, in his account, and he says that he collected this bug in New Jersey, seems to agree with these descriptions. Painful wound, feeding on bed bugs. Well, the problem is that kissing bug bites are painless, which makes sense. If they were not painless, they wouldn't happen. People would wake up and remove them. I mentioned they feed for 15 to 20 minutes. This has been confirmed by observers of Trypanosoma sanguisuga feeding on humans that reported that people just did not notice it. And also 12 out of 481 subjects just had a mild reaction. So they get bit and it just gets a little itchy, but that's about it. They would sleep through it. And another evidence of the fact that people will sleep through it is that patients presenting to emergency rooms with anaphylaxis, and this does happen, the people are allergic to kissing bugs, are rarely aware they got bit. And so they just simply awake in the middle of the night with intense itching and difficulty breathing way after they, or at least after, depending on the person, they got bit. So, which means that Bletchley may have been confused between what he thought was a Triatoma sanguisuga and, remember, the masked bandit, which does occur indoors and does feed on bed bugs. And a lot of these assassin bugs are quite painful when they bite you because they're killing machines. They're there to kill the insect. They don't have to be particularly stealth. They have to be stealth about getting it, not in terms of not hurting. So it's possible that, in fact, Bletchley did not report Triatoma sanguisuga in New Jersey. So question becomes, do kissing bugs actually occur in New Jersey? Well, actually, as it turns out, yes. And this specimen, which was collected by a Cumberland County homeowners in a bedroom in June 2016, is actually in my desk right now. I have that specimen. So it was taken to the Rutgers Cooperative Extension. This is in Cumberland County, which is one of the southernmost counties in New Jersey. It was identified by Joe Ingerson-Maher, a vegetable IPM coordinator, as Triatoma sanguisuga. Yeah, it is Triatoma sanguisuga. And which means that they're in New Jersey. How long they've been in New Jersey, it's kind of a bit of up to grabs right now. I've looked through the literature. The only example was that Bletchley statement, and seems now a little bit more in question. This is from Klotz et al. A distribution of kissing bugs. And what you will notice is that basically all of the eastern United States is listed as having sanguisuga, Triatoma sanguisuga. A few others have also Triatoma lactularia. They're really easy to confuse. Basically, lactularia is a hairy version of sanguisuga. And the distribution that you'll see here, so basically New Jersey only has listed sanguisuga, so does Virginia, Pennsylvania and Maryland have both, Tennessee has both, North Carolina has both, but then Indiana, Ohio, only one, Arkansas, Louisiana, only sanguisuga. So basically, the more I read about it, it's clear these two are quite closely related to each other, easy to confuse, may actually be part of a species complex, and be kind of interesting to take a look at. So it's very possible we actually either have both lactularia and sanguisuga in New Jersey, or that they actually are a single species with a bit more variability than we thought. So kind of question that everybody really wants to ask is there Chagas disease in New Jersey? Most likely, but the fact is that prevalence and incidence are unknown. If we look across the United States, we have estimates based on blood screening that about 300,000 to 1 million residents are currently infected with Trypanosoma cruzi. And that's from that study, Byrne and Montgomery from 2009, which is already a little out of date. In 2011, Byrne again mentioned the same numbers. So we've had some developments since that, if anything, indicate more transmission. But overwhelmingly, these are travel cases, the 300,000 to 1 million. People go to Central and South America, become infected there, or have been infected there. Remember, you remain infected with this pathogen for life. So there's a lot of cases, most of them are travel cases. And in fact, there have been very small, very low numbers of local transmission. Only 7 had been completely sort of vetted as being local transmission from 1955 to 2006. But there's been a very significant recent increase, 5 only in a small little sample in Texas in a study done in 2011. And also after blood and organ screening increased, which only started in 2007. So we're actually starting to see more transmission. And in fact, in every eastern state where testing has been conducted, Triatoma sanguisuga, the same species we have here in New Jersey, has been found infected with Trypanosoma cruzi, the agent of Chagas. Like I mentioned, 40 to 60% in adult bugs in Louisiana. So again, as I mentioned, the adults are more likely to be infected, but even the nymphs are infected. They've just lower rates, 10%, 12%, 15%, depending on the stage. They all have to feed on blood. So we're going to modify this to question, could Chagas become a problem in New Jersey? Well, maybe. So the one thing that is pretty clear is that there are definite similarities to Lyme disease. We have a pathogen that causes some very small proportion of acute symptoms and then sort of remains dormant. In many cases, we have the people have no symptomatology whatsoever. In a considerable number of cases, 20 to 40%, there are consequences like a heart attack, 20, 30 years after they were infected. So what is needed for it to become a problem is for highly infected reservoir hosts to show up. Could it be possums? There aren't that many possums. Could it be dogs? And we'll talk about that in a minute. We also need sort of increased human exposure to infected vectors. And it's a little unclear how exactly that would happen, but that's, again, sort of the similarities to Lyme disease. Shift to more effective vectors, more likely to bite humans. That would be another way in which you might have Chagas become a problem in New Jersey. And that's where a recent proposal has come that bedbugs could become a vector of Chagas. And this is very controversial. This is actually a picture from Mike Levy, a professor at the University of Pennsylvania, that originally made this proposal. And he did a set of, I have a study in here in a minute, but he basically is proposing that bed bugs, which have been increasing in abundance across the northeastern United States and across the United States in general, over 100% increase per year, that they could become vectors of Chagas. And he argues this from laboratory studies that show that bed bugs do become infected after biting a host that is infected with Trypanosoma cruzi. They show that infectious T. cruzi parasites are excreted in the bedbug feces. Remember, that's the mode of transmission. They bite and then they poop out the pathogens. That has been demonstrated. And that hosts that are bit and then pooped on by infected bedbugs do become infected with Trypanosoma cruzi. Now, most of these studies, actually all these studies, have been done with laboratory mice. And there's some, Mike was just here at the School of Public Health giving part of this talk last week. And there's some really interesting experimental design that he had to deal with. But so we have bed bugs. They can become infected. The pathogen develops in their midguts and is excreted as in an infectious stage. And the hosts that are bit and then exposed to the excrement of the bed bug can become infected with T. cruzi. We also know, and there's the study here, so we also know, it's also shown that dogs that eat infected bed bugs can become infected with Trypanosoma cruzi. Remember that the pathogen is infectious in the gut of the bug. So and they can become infected. And also, and what you're seeing here on the left is a series of steps that are required for a bed bug to actually become an effective vector of Chagas, where you would have, you have to have enough bugs per host, enough biting rate, the percent of bites that infect the vector has to be high enough, percent vector surviving to infectivity, the vector lifespan, the biting rate, and the percent of vector bite events that infect the host. All of that has to be measured. Mike just showed recently that there is no cost to the bug to be infected with a pathogen, the bed bug. So this survivorship and lifespan seems to be fine. And if anything, the percent of bugs per host, in this case, bed bugs per host, is significantly higher than we see for Chagas, the kissing bugs, The biting rate is also higher, and that actually is important for this transmission on a exponential of 2. So that's why it's here twice. So the possibilities are there, but in fact, there is up to now no real evidence anywhere that bed bugs are transmitting Chagas pathogen, so Trypanosoma cruzi. So, and I think I left enough time for discussion. In conclusion, so do vectors of the agent of Chagas disease, Trypanosoma cruzi, occur in New Jersey? Yes. Trypanosoma sanguisuga and possibly also Trypanosoma lactularia. You know, we have one, obviously, but the fact is there hasn't been much of a surveillance for these vectors in New Jersey at all. The fact that we have one, and by the way, it was found in this resident's bedroom in Cumberland County, indicates they're here. We don't know how common they are. Are they infected with Trypanosoma cruzi? We don't know. We know that Trypanosoma sanguisuga is a competent vector of Trypanosoma cruzi, and there shows very high rates of infection in the southern U.S. states where it has been measured. Does Trypanosoma cruzi infected wildlife occur in New Jersey? And I should end, it doesn't have to be wildlife, could also be dogs. We don't know. But we know that opossums occur in New Jersey, and we know they're excellent reservoirs, and we also know we have dogs. Dogs as can also be reservoirs of Chagas and of Chagas pathogen. We know that from studies in New Orleans. So we don't know, but it's possible. Is there ongoing transmission of the Chagas pathogen T. cruzi in New Jersey? We don't know. We've really just starting to ask questions. And are bed bugs important in Chagas disease epidemiology? There's no current evidence, but it's a hypothesis of future risk. There's a series of things that really need to happen for the bed bugs to be important. And some of it, I've actually been discussing this with Mike Levy. We still don't know, for example, how infectious people are. People that are infected with Trypanosoma cruzi, how infectious are they to a bed bug? Because it's hard to do those experiments. You can't really go around, sticking bed bugs onto people and ask if they become infected. That used to be the strategy, not anymore. And so what we really need are surveillance approaches, and we need to get sort of an understanding of how big of a problem is it, and what is it sort of just starting to rumble? Is this something that is not an issue? I think the summary conclusion that I just presented, at least to me, indicates that it could become a problem. To be honest, we don't even know if it is a problem already, because there is really no surveillance. We need surveillance approaches. And since I don't really work with humans, I'm not proposing serosurveillance of people. Maybe some of you could consider that. I look at it as a sort of strategies for surveillance, and in particular, cheap approaches for surveillance. Now, one approach that has been developed in Texas that has 8 different species of Chagas vectors and is this citizen science surveillance. So the kissing bugs and Chagas disease, you can, the website kissing bug at TAMU EDU at the University of Texas is excellent. It has a lot of information. What you're seeing here is the cover of a several-page brochure on Chagas that is being provided to the residents. They basically have residents send in any bugs that they think might be kissing bugs, and then they send them to TAMU, and they look for pathogens, and so similar to what is already being done for ticks across parts of North America. So this is an interesting idea. The tricky part is we go full circle back to kissing bugs versus assassin bugs. So here are kissing bugs. Here's Triatoma sanguisuga, the one we're concerned about here in New Jersey. Here's Triatoma dimidiata, Rhodius pluralixus. You'll notice they're also called the cone-nosed bugs because they have these long, extended noses. And but the fact is that, so they all have this, and then here's the mouth parts, sort of recurved, long mouth part, very straight. So remember that here's the key features of non-kissing bugs. So here's the wheel bug. This is a Reduviidae. These are not Reduviids. These are other families, but they also have the same kind of mouth parts, but they have sort of more rounded heads. So this wheel is very characteristic of the wheel bug. These kind of leafy legs are the characteristic of leaf-footed bugs. These are assassin bugs. So they're bugs, actually, these are not, this is the wheel bug is an assassin bug. The other one are predatory bugs that we want to keep because they're important for biological control. This is a squash bug that actually is a pest. But here's a comparison between, on the right, so D, you'll have the kissing bug that has the cone-nosed, sort of elongated head with the proboscis sort of straight back, while the black corsair, which is an assassin bug, is more sort of a rounded, this is a bug that is going to stab an insect. So being able to tell these apart is going to be a bit tricky. And another one we have here a lot is the brown mummery stink bug, which also has that mouth part that tend to quote unquote freak people out. So that feature means that if you're trying to do something like this with citizen science, you're going to have a lot of non-kissing bugs showing up at our doorstop for identification. Could be an interesting project. It's a possibility. The other one is actually using xenosurveillance. So going to the concept of One Health, which means there's a couple of papers recently published, the potential of using canines, so dogs, as sentinels for re-emerging Trypanosoma cruzi transmission. This was a study done in Arequipa in Peru, showing that, in fact, the dogs could be an early signal of the presence of T. cruzi in the Chagas vectors. They eat the bugs and become infected, and they also get bit by the bugs and become infected. And in fact, also in Texas, shelter dogs are proposed as being used as sentinels for Trypanosoma cruzi transmission. So, so using dogs as reservoirs of T. cruzi, and not only because they may play a role in reinitiating transmission, but also they could serve as indicators and maybe simpler to test than people, and maybe also simpler than trying to comb through thousands of non-kissing bugs provided by the citizens. So that's my summary. Here's my contact information. Any questions?
Thank you so much, Dina. We have several questions.
Okay.
The first one, and I'll read through each, is symptoms occurring after decades, like the cardiac and the GI symptoms that we had discussed. How would that be diagnosed and know that it might be related to Chagas?
All right, so I'm a doctor, but not a medical doctor. So my understanding of that from reading literature is that you actually see nests of the trypanosomes in the heart. You see the heart is modified, and so there's clear clinical signs that can be seen in autopsy that correspond to the damage created by T. cruzi on the heart.
Okay, thank you. If you find a kissing bug, what's the best way to dispose of it?
Actually, that's a very good question. Thank you. So remember that, as I mentioned, kissing bugs, the Trypanosoma cruzi is infectious even outside of the bug. So the bug may be covered in feces or may be exposed to feces. So do not handle a kissing bug with your hands. Use a Ziploc bag to pick it up, or a small container to pick it up. Also, if you find any feces, because they are basically pooping in the area, you have to bleach it and to be able to kill the pathogen. So that is something you can, by touching a kissing bug, you can be infected with Trypanosoma cruzi if it were to be present. And then if you were to touch your eyes or your mouth, you could infect yourself. So handle with care.
Great, thank you. how is the disease treated? Do they use something like doxycycline? And is there a blood test available for it?
Okay, so no doxycycline. This is not a bacteria. This is a pathogen. So this is a protozoan. There are a few, basically chemical treatments that none of them are actually approved in the U.S. If you were to want to treat Chagas, you would need to get the chemistry, the treatment from the CDC directly. What was the second part of the question?
Is there a blood test available?
Yes. So there is. So most of the strategy for detection of presence of T. cruzi is serology, IgG and IgM. The pathogen basically circulates inside the cells. They lose their tail, they lose their flagella, go inside the heart cells and the smooth muscle of the intestinal cells, and then on regular basis they come back into circulation. So you you have episodes of the trypanosomes sort of in circulation, and it can re-energize the antibodies. You can also in those stages detect the pathogens with a PCR. But that's, again, it's a bit of a small window that may reoccur, but it's a short window. So serology is usually the strategy. I don't know how much better they are, the serological tests, than the current existing ones for Lyme. So all of these intracellular pathogens can be a little tricky to diagnose, so for sure. But there are multiple. There's a PCR available for detection.
Great, thank you. Are there precautions that should be taken when cleaning fruit?
When what?
When cleaning fruit?
Yeah, I know. Yes. So again, let's not completely freak out here. So we have no evidence at this point that Trypanosoma cruzi is occurring in vectors in New Jersey. We should always clean the fruit. All sorts of bacteria and other pathogens can occur. I don't know, to be honest, if I know that bleach will clear up these pathogens. I don't know if the normal sprays that we are using for washing fruit will deal with something like T. cruzi on the surface of a fruit. I would have to research that.
Okay, thank you. Do you think climate change is likely to impact the spread further north?
Well, so that's kind of an interesting question. And I almost included some of that into this presentation, and I thought, we're going to discuss it. So we're definitely seeing a shift and primarily work on mosquitoes, and we are seeing a shift in mosquito species. We just recently published a paper in EcoHealth last month showing species that were more southern species moving across New Jersey into, right now, Culex erraticus, a mosquito that was not present here about 30 or 40 years ago, is now present in every single New Jersey county. So that also goes for this Triatoma Sankey Sugah. After having thought that Bletchley had found the species here in 1926, which made me think, yeah, it's been here. And then realizing that there were some inconsistencies with the description he was giving of the bug, and then having found, having in my possession what I believe may be the only actual specimen collected of the species in New Jersey, and that's in Cumberland, which is one of the most southern counties in New Jersey. It's possible that the species is now moving north, and we used to have some pretty strong winters, cold winters. These are clearly, if you look at the distribution of all the 11 species, they're more, southern species. They probably cannot handle the winter very well. But two things happen that allow, insects to deal with cold weather. One is global climate change, if it gets warmer. But the other one, and it's going to be a little hard to separate the two, is that if they go indoors, if they're associated with people's houses or garages or basements, it's not that cold there. So we could have, and we have examples of that in other vector species. So I don't know. It certainly is possible that if it gets warmer, or let's put it this way, if it gets less cold in the winters, species that normally wouldn't survive here would be able to survive. It's also possible that even if it's not the temperature of the climate, but it's in fact the temperature in our houses that are making these species more likely to survive here, that can also happen. But it clearly, the other thing actually, by the way, I should mention is that, and this is, literature is a little confusing on this. In some cases, they argue that, I've read in the literature that Sugah can take 2 years to develop fully from egg to adult, which means that it's sort of developing slower at colder temperatures. And a species like that can do that may be able to sort of hunker down as a third or fourth instar nymph, and then develop spend the winter that way, and then develop the next spring, develop fully to adult. And in fact, those kinds of situations may make it more dangerous from a disease transmission, because an infected nymph could then, when feeding on whatever host the next year, could then infect the young of the year of that other species, say possums, and actually create increase the likelihood that you have high infection rates in the reservoirs. We see that in ticks. So I guess the question was, can warming temperatures facilitate the expansion and the increased abundance of a species like this in New Jersey? Yes, I think so. Is that the only thing that could be driving potential changes? No, we can have them become adapted to houses or our habitations be also part of that story.
Okay, thank you. A question about the incidence of Chagas in agricultural workers nationally. Are they more prone to infection?
Actually, that's a very good question. I don't know. I haven't come, maybe somebody in the audience does. I have not looked at that particular number. Yeah, don't know. Okay. I would expect that, but remember, these are night biting insects. And so it's not necessarily that just because you're outdoors, you're going to be likely to be bit. You would have to sleep outdoors. So if you would argue that farm workers may be living in conditions that may be more likely to expose them to night-biting insects, then yes, otherwise no.
Okay. How do you know if, oh, this is more like fruit, so I'll pass on that one. Are the cases that you mentioned lab confirmed? And if so, were they confirmed by New Jersey or the CDC?
Which cases? Is that the 7 cases that I mentioned that were local transmission?
I think I know the person. If you can maybe add another comment in response to that question, I believe that comes from Sussex County, and I'll come back to that one.
Yeah, and by the way, none, if you're talking about the 7 cases that had been confirmed between 1955 and 2006, none of them were in New Jersey. In fact, none of these cases, no cases have been confirmed in New Jersey for local transmission of Chagas. I was talking about, and in fact, it's part of the heading of that slide is in the US. So, because there really hasn't been any work on Chagas in New Jersey. Okay. That I know of.
I think they were on, okay, they were confused on that. I just see the comment.
Okay.
Right, I see the comment about substandard agricultural housing, which you addressed. I believe that is the last of the questions. I'll give folks one more chance if anyone wants to add a question. And in the meantime, Dr. Fonseca, as disturbing as some of the images were, that was an excellent presentation, and we certainly learned a tremendous amount. So thank you very much for taking the time to share this with us.
Well, thank you for the experience. It's the first time I've done a webinar like this. It was.
Well, we'll have you back whenever you'd like to come back. I don't see any other questions coming in, so I thank all of you for joining us this afternoon, and luckily we were able to power through without power. So I think this is the new one for us. We do have another program coming up in early November, on November 6th, regarding recreational marijuana, and we'll be sending that information out. Someone is asking for your contact information again, and okay, you see it up on the screen. Great. I did send out the handout for today's presentation, but because of file size, that became an issue for some. So if you did not receive it, I will feel free to send me a note and I will send it directly to you. With that, thank you all so much. And you have a great day. And Dr. Fonseca, thank you again very much for your time. We really appreciate it.
Bye-bye. Bye, everyone.
Bye-bye.